Hello, ladies and gentlemen. My name is Jason Tu, acting as the Principal Scientist of NFV SDN Solution of ZTE. First of all, I want to thank Layer 123 to have the opportunity for the industry talking about 5G, especially in this special time. Okay, so we understand the 3GPP defined 5G as two-phase. Non-standalone as the beginning and standalone as the target. Of course, different countries have the different strategy of their migration to the target architecture of the 5G. But some of the countries, for example, China, has a very aggressive strategy, migration to their 4G network and some of the directly to the standalone architecture. Okay. So today I want to share the story about the Chinese operator and the Chinese 5G market progress. Okay, thank you. Let's go to the first slides. So the phase one of the Chinese operator of the 5G project is began from the last year. Okay, at the middle of the last year, the 5G license issued, and you can see about 150,000 of the base stations deployed in last year. And of course, they are now standalone. And you can see the quality of the base station is also 25% of the world at that time. So this is, of course, the beginning stage of the Chinese 5G market. Of course, it starts with the non-standalone. But for the second phase, this year, China has a very aggressive strategy to deploy their 5G. So you can see more than 500,000 base stations are deployed in this year, and all of them are dual-mode base stations. That is mean they support non-standalone and also standalone as well. And of course, China operators are also deploy a very large scale of the standalone network of 5G for the countrywide. So you can see from this year, almost 1/3 of the RAM base station is deployed in China, and the subscriber of the 5G of the whole world is about almost 1/3 is also in China. And it was completed in the 2025. The total base station of the whole world is more than half is in China, and the coverage of the population in China were up to 50%. And at the same time, the world is almost 25% as well. It was predicted by GSMA. So you can see from the China market, they do have a very aggressive 5G deployment strategy, and they are doing this project. Okay, so this is a picture. So the main operator in China, their strategy, migration from their 4G network to the target 5G network. Of course, as I mentioned, they began with their 5G network with a non-standalone. But from this year, they do have a great emphasis from the non-standalone to standalone. That is mean they invest more on the target standalone architecture. You can see from the China Mobile, and this year is investment on the non-standalone because of the 4G. Some of the area that do have increased requirements of 4G, but standalone take almost 50%. And from the next year, the standalone will be occupy the most percentage of their investment. And for the area that not deploy 5G last year, they are directly deploy standalone network as the beginning in the 5G network. And the same situation happened in China Telecom and China Unicom. So you can see they skip to, for the country that not deploy non-standalone 5G last year, they are skipped to standalone network in this year. Okay, so ZTE, of course, as the pioneer of the 5G solution, we helping the China Mobile to release the world's largest commercial 5G standalone core network for China Mobile. So, China Mobile have the two logical independent 5G standalone network, which is one is to C, the other is to B. And ZTE takes almost 1/3 market share of the world's largest commercial standalone network. Okay. And this is our what we call the Common Core. ZTE Common Core is kind of a cloud-native core network which can support virtualized EPC, non-standalone, and also 5GC for the consumer and also 5GC for the business. So you can see from the picture on a unified cloud platform. So we do deploy Common Core for expansion of the 4G network, for the EPC and the non-standalone, and also a logical independent 5GC for the consumer, and together with a logical independent 5GC to the vertical industry, and also for the user profile. So we have a different distributed solution for the country, for the city, for province, and as well. So we do have a unified core network, cloud native based, for all scenarios, including 4G and non-standalone. Well, the same situation happened in China Telecom and China Unicom. In China Telecom, ZTE, the 5G core network, take almost half market share in China Telecom, and we take 1/3 market share in China Unicom as well. Okay, let's come to the technology differentiation of the standalone and the non-standalone. Of course, which is identified by target architecture. Standalone is a service-based architecture, which is running on cloud-native network, and it was networks could be network slicing for different virtualized private network for different industry and application, and it supports mobile edge computing for the low latency and for security and some special features. And of course, it's stateless. It's a new software, which is most of element is stateless. Could be a redundancy and with smoothly. Okay, so this is a technology advantage for the standalone. Okay, but how is the business model? So we invest so much money on the standalone architecture, so we need to get some money back. So the business model is also very important for the 5G standalone. So we can see from we do have a three model of the business model. Which one? The first one is the B2C, which is similar to the 4G. We sell more traffic package to the retail consumer. We encourage them to watching 4K videos and more entertainment, which is using more bandwidth. Second is about B2B. We are selling network slicing as a virtual private 5G network to the vertical industry and enterprise, which is encouraging them to using this 5G virtual network to deploy their special vertical applications. And the last one, which is the most important and interesting one, is what we call the B2B2C. We selling network slicing directly to the vertical industry, and the vertical industry integrated their service logic together with their network connection to their consumers. So in this way, the retail consumer did not pay any traffic fee to the operator, but they need to pay the total money to the service provider, and of course, service provider need to buy network connection, which is guaranteed by SLA from the operator. So that is what we call the B2B2C, and also the operator can launching what we call the 5G slicing store to selling slice easily and how to say, to the vertical industry and help different vertical industry to binding and deploying the network slicing easily. Well, so let's come to the slicing. So as we understand, the investment of the 5G standalone network is huge. So we need to have a service to encourage the population to use it and get some revenue. So to my understanding, network slicing maybe is the first population vertical application from the standalone architecture, which can get new revenue for the operator. So that's we can define it network slicing in 3 types. So the first type is the full software slicing. So everything is because of 5GC and most of the 5G is on the cloud native network. So for different network slicing, they are sharing the unified platform. I mean, the hardware is the same, but using different software and control policy, priority for different group of users. So this is what we defined as the soft slice. The other is called about the hardware and the software slice. There are a lot of elements in the 5G end-to-end network. For example, the user plan, UPF, could be isolated, deployed it only for some enterprise or application. It's not shared by other applications. So in this one, maybe the control plan is shared by everybody, but the user plan, especially for the UPF, can have a dedicated hardware, could be only for one application. So in this way, the SLA, I mean the quality of service, could be guaranteed better compared to the first one. So the last one, which is the most important and most high-level guaranteed SLA, is the hard slicing. So everything, I mean from the transmission, 5GC control plan element, user plan elements are all independent from other slice, and they can have an independent hardware from other slice. So in this way, the hardware slice has the high priority SLA guarantee compared to the two, the software and hardware software-based one. Okay, so let me get some example. The first one is we are talking about e-gaming. So nowadays, the e-gaming company are providing their service on the internet, which is the best effort. So by introducing network slicing, I mean the e-gaming company can buy a special ultra-low latency together with mobile edge computing network slicing software-based for their high-level user. In this way, the user, which is paying more money, can put into the software-based slice, which can guarantee their bandwidth, SLA, and also latency. So compared to the user is on the best effort network, those high-level user can experience better user experience because they are acting more agile and they can experience better picture quality, for example, 4K as well. So in this way, entertainment application can use software-based slicing for their high-level user, I mean, for better service. Okay, the second is the software hardware slice. So this is an example from the port. So you know, port is also far away from city. So in this way, the control plane is on the cloud native plane, is on the central, is software based, but the user plane is distributed to the edge, which is on the port itself. So in this way, the bandwidths are guaranteed because the UPF are not sharing with other applications. So the SLA is guaranteed better, and all the control is I mean the data video flow is not go out of the port. So in this way, the bandwidth, latency are also guaranteed. So it's better, and also it's more expensive. So the last example is from the mine. So I think the mine is always far from the central city, is on the desert, on the forest, and the transmission to the data center is hundreds of miles or even thousands of miles. So in this way, if we still put the control plane on the central data center, is maybe more risk because the transmission from the central data center to the mine is a risk, not only for the security, but also for the latency and also for the risk of the disaster. So in this way, we can put everything, control plane, user plane, and also the whole 5GC directly on the mine itself. So everything have an isolated platform with the hardware and the software are guaranteed in the most priority level. So in this way, you can see even the transmission from the mine to the central is cut. So they can still providing service locally. So this is most, of course, they can provide the best SLA as well, and of course, the cost is the most expensive. Okay, let's have a conclusion. So, of course, we can understand the standalone supply chain is much faster, including terminal, so we can do more terminal everywhere, almost in the world is not a problem, and the terminal is also cheap and price is acceptable, and also standalone get more economy because in some city and country we can see, especially from the South Asia, some of the country are selecting the strategy migration their 4G network directly to the standalone target network. So hoping the non-standalone stage is not a choice for this country, and sometimes it's not too expensive. Okay, the third one is talking, as I mentioned. Of course, standalone is the target architecture, and network slicing for vertical industry will probably be the first profitable standalone service, and it hope to get a new revenue source, which is a B2B or maybe B2B2C for operators. So it can get a new revenue source for the operator. We can think about this. And the last one, to be business model are metro fast. So it's very important for the operator. So nowadays we are selling, of course, data packager to the consumer, and maybe in the future, not far away, so we can selling network slicing to the vertical industry, which is more profitable, to my understanding. And I think that's all for my slides. And thank you very much for your attention.